Hello everyone, welcome to another kinetic tutoring episode. Today we're taking a look at something a little different. We're deciding to switch over from AP Physics C to AP Calc PC or AP or Calc 2, whatever you want to call it. I'm still going to be doing some physics content, but I'm also going to be adding in Calc 2 content as well, just to add a little bit of variety, because I know some people may need help in Calc BC, Calc 2 instead. So I'm going to try to add a little bit of that in there as well. So the first topic we're going to be discussing is going to be trigonometric substitution. And so let's get straight into it. Alright, so first let's start off with our basic trig identities that we learned a long time ago. And this one is the one that's going to be crucial. Sine squared theta plus cosine squared theta is equal to 1. And there's another one that's derived from this identity. It comes from dividing all three of these terms by cosine squared theta. So we get sine squared theta divided by cosine squared theta, tan squared theta. Cosine squared theta divided by cosine squared theta gives you 1. And then 1 divided by cosine squared theta gives you secant squared theta. And there's another one that comes in quite handy. I'm going to write it in the top corner of the screen just in case I don't forget. So we get sine squared theta is equal to 1 minus cosine 2 theta over 2. And there's also the cosine variant of it. Cosine squared theta is equal to 1 plus cosine 2 theta over 2. Alright, now you guys might be wondering, how does this come into play? Because here we're not dealing with any trig, no thetas. So how does this come into play? So as you can see here, we have a certain variable to the power of 2. And a constant to the power of 2, and then we have a constant to the power of 2 here as well. So what we're going to want to do is to get this in the form of this. So, but none of these quite work. Here we have a positive variable, and we're subtracting a constant, a positive variable, and then a negative constant. So, I mean, if we take a look at the first or the second, actually, or no, just the second. If you take a look at the second equation, just by moving this one around, we will have said variable subtracted by said constant. Now, it's not the same constant, but what we can easily do here is multiply the entire equation by a certain constant, let's say 5. We can just multiply it and make this 5 tangent squared theta is equal to 5 secant squared theta minus 5. And that works perfectly fine. So now, how does this apply here? So, since the constant is 49, we want to have an equation that looks like this. 49 tangent squared theta is equal to 49 secant squared theta minus 49. The issue is, how do we get 81x squared to equal 49 secant squared theta? And I mean, that's pretty simple. You just set them equal to each other. 81 x squared is equal to 49 secant squared theta. Now from here, you're going to have to find the value of x. In order to do that, we'll divide by 81 first. 49 secant squared theta over 81. And then square root both sides, and you will get your x. Square root of 49 is 7. Square root of secant squared theta is secant theta. And the square root of 81 is 9. So now we have our x, we can erase all of this over here. Slowly but surely. There we go. So now let's plug in this x to our equation. Have our integral square root 81. Plug in this for x, 7 secant theta over 9 squared minus 49. And we'll keep the x cubed and the dx the same for now, because something really interesting happens as you continue with this equation. So once we expand this, we get what we get here, because this is just the x term being squared. So we'll get square root 81 times 49 secant squared theta over 81 minus 49 over x cubed dx. From here, these two 81s cancel, so we can say that this will be 49 square root of 49 secant squared theta minus 49. Write in the rest again. But wait, this looks a lot like the formula we had. 49 secant squared theta minus 49. So we know that this, by definition, is just 49 tangent squared theta. So we'll have the integral of square root 49 tangent squared theta over x cubed dx. From here, and then we realized that this, we're able to take the square root of it. For square root of 49, 7. Square root of tangent squared theta, tan theta. Now, I'm going to, okay. That's fine. I have it written down. That's not an issue. Alright, so we have square root of 7 tan theta over x cubed dx, and our x is equal to 7 secant theta over 9. Problem solved, no worries. So now let's plug in our x for everything else. We'll get that the integral, let me draw that integral sign a little better. The integral of 7 tan theta over 7 secant theta over 9 cubed dx. Now let's get dx in terms of theta. What we'll do is to take the derivative of both sides. Derivative of x is going to be dx. The derivative of 7/9 secant theta is going to be 7/9 secant theta tangent theta d theta. There you have it. Now let's just bring this home really quick. Now we know that multiplying by or dividing by this is the same thing as dividing by its or multiplying by its reciprocal. So we'll have 7 tan theta divided by this is the same thing as 7 tan theta times 9 cubed over 7 cubed secant cubed theta. Alright, now from here we're going to bring in our dx as well. So we'll get times 7/9 secant theta tan theta d theta. Let's do a little bit of cleaning up, see what we can factor out from here. This 7, and 2 of these 7s cancel out. One of these 9s and one of these 9s is going to cancel out, and we're left with, oh, and also one of these secants as long as this secant, and then we're left with the integral, this tangent times this tangent. We'll put the 9 7s on the outside. We'll get tan squared theta over secant squared theta d theta. And from here, the last step is we notice that secant squared theta is the same thing as 1 over cosine, secant squared theta is the same thing as 1 over cosine squared theta. So we can put cosine squared theta in the numerator. And tangent squared theta is sine squared theta over cosine squared theta. And look at that. These cancel out. We're just left with sine squared theta d theta. And here is where the equation I gave you guys earlier comes in very useful. Sine squared theta is equal to 1 minus cosine 2 theta over 2. So now we can just say, we'll take this 2 out to the outside. We'll get 9/14 integral 1 minus, this is a cosine 2 theta, 1 minus cosine 2 theta d theta. Final step, do this simple integration. We'll get 9/14 theta minus 9/28 sine 2 theta plus c. Going from cosine to sine, yeah, the sine stays the same. So there you have it. This is how you solve. And yeah, that's how you go about solving this problem. Let me know if you have any questions or concerns. Leave them in the comments below. I hope this video helped. I hope you guys enjoyed it. If so, make sure to press the like button and subscribe. And that's all, and I'll catch you guys next time.